In this video, we're looking at non-linear simultaneous equations. So non-linear simultaneous equations involves equations which have a power that is equal to 2 or greater, non-linear. So the substitution method is usually used to solve these type of equations. So what we're going to do is we're going to start with our example down here, where we have y equals x squared and 2x plus y equals 0. So what I need to do is first I'm going to write these equations down, and I'm going to label them to make things a little bit easier when I'm talking about them. So this from now on is going to be equation 1, and this is going to be number 2. So what I want to do now is I want to substitute in equation 1 into equation 2. So what I mean by that is, notice how this has a y here and this has a y. That means they're the same thing. So in our example, we have y equals x squared. So what I can actually do is put this x squared in here where the y is. So what I end up with is 2x plus x squared equals 0. Now, all I'm going to do here is just rewrite it to make the highest power at the front. That's a really good practice. Now what I can do is factorize down this here. So look for my highest common factor. So I want to find my highest common factor, and in this case that's going to be my x. So what I can do now is bring the x out the front, and x times x gives me x squared, so x goes in here, and then 2 times x gets me 2x, so 2 goes there. Now when you've got something like this, what I need to do is find out what this x equals to make it equal 0, and what this x equals to make it equal 0. So whenever you've got a pronumeral at the front, like this front x, that has to equal 0. Alright, so I know that that x is 0, and then over here I know that x plus 2 needs to equal 0. So what I can do is go minus 2, and I end up with x equals negative 2. So now I have my two x values. So over here, x equals 0, and x equals negative 2. So a common mistake here is people stop at this point. The problem is we need to find all the variables. We need to find what x equals, but we also need to find what y equals. So now that I've got that, I'm going to have to substitute these values back up into either equation 1 or 2. Now to make things easier, I look at these two and I go, well, I know y equals x squared. That's probably the easiest. I'm not going to have to do any rearranging. Whereas if I used equation 2, I'm going to have to do some rearranging. So down here, I'm going to use y equals x squared. And all I'm going to do is substitute in these two values. So for my first value, I'm going to get y equals 0 squared. And then over here, I'm going to get y equals negative 2 squared. So what I end up with is y equals 0 here. And what I end up with over here is y equals 4. So at this point, it's probably good practice to write down the solutions. So you would say the solutions are, and then down here I can say x equals 0, y equals 0, and x equals negative 2, y equals 4. So those are my solutions to these problems. Now that's all you need to do with nonlinear simultaneous equations, is you look for the similarities. Sometimes you may need to do some rearranging. So in our case, we didn't have to. We said y equals x squared. So what I did is I changed any y in the second equation to what it equaled in the first. So that y became x squared, and I ended up with 2x plus x squared. This stage, you just factorize it down and try to find out what the solution's going to be. You may end up having to use the quadratic formula. In this case, we just had to factorize. But you end up with some values for x. Once you've done that, remember you need to substitute those back into the original to find out what your y values are.